I'm going to start with a question. How many of you, when you were younger, or even to this day, looked to the moon and wondered about those footprints that are up there? Many of you. And then asked yourself, how can I do that? How can I explore space? Well, I'm going to talk about commercial space exploration. And maybe we can talk about a lunar base as a part of that scenario to answer some of those questions. So before we go there, let me take you back to the beginning of the 20th century when the Wright brothers were beginning in the aviation industry with an aluminum engine. Lightweight aluminum was a breakthrough material at the time, scarce to get, but it was critical for design. Now let's jump back to now, beginning of the 21st century, with the continual advancement of lightweight materials and innovations in the way that aircraft are being designed. And what happens is that we see now, today, we're on the dawn, like the Wright brothers were 100 years ago, of a revolution in aerospace transportation. There are companies that are building spacecraft to take passengers to the edge of space for a short duration experience of microgravity as tourists in scientific endeavors with the ultimate goal of having a point-to-point network around the world to get anywhere within 2 hours with a suborbital flight. There are companies building space capsules to ferry our astronauts to the International Space Station and for resupply missions. And those same space capsules will eventually be ferrying passengers to private space stations, currently being developed right now for launch in the next decade. There are companies building business models to go beyond low Earth orbit and enter into the solar system to mine asteroids, go back to the moon, and mine the moon for its resources. Now, what's common about all these companies? NASA is not driving these missions. Let me repeat that. These are not NASA missions. These are private commercial ventures. The private sector is leading the way to space. How did this all start? Billionaires that made their fortunes in other industries decided to turn their attention to the resources to space exploration and the applications that it could have. Former NASA administrators and astronauts who have left the agency to begin their own space companies. And now there's a third wave of organizations getting involved. Communities. Houston. The city of Houston has a space program. And I don't mean a space program because they're close to NASA Johnson Space Center. They have their own space program. The Houston airport system is building a spaceport to service this commercial spaceflight industry. Brownsville, down at the tip of Texas, is trying to lure a company called SpaceX to locate a spaceport there to launch from Brownsville rocket ships to go to Mars, and those rocket ships to shoot the capsules to low Earth orbit. Now, how about San Antonio? Can San Antonio have a space program? If you look at the map on the bottom of that screen there, you see between Houston and Brownsville, San Antonio in the middle. The Texas Gulf Coast is poised to be a mecca of human space exploration in the coming decade and years beyond. And that's why I want to talk to you about a lunar base as a natural progression of this commercial market and the position of our city to be ready to take advantage of these examples. Here's a site we found on the moon about 3 years ago. It's discovered by a Japanese satellite called the Cayuga satellite. It found this hole in the ground, an opening in the lunar surface. Essentially, it's a pit, big, deep pit, 60 meters in diameter, about 150 feet deep. is thought to be a skylight. Now, a skylight is an opening to caves in the lunar surface. Caves! A cave on a planetary, distant planet. Can you imagine that? Now, I'm an architect, and that's really excites me architecturally for its potential, but also because as far back as when I was 7 years old, living in Germany at the height of the Cold War, a friend and myself found this cave, and we crawled on our belly to the end of it in the darkness, and at the end of that cave, we found a chest of gold coins. Well, they weren't gold, they were German coins. So that sense of adventure and discovery into the darkness of that cave has never left me. Can you imagine the first missions of humans to this cave? 250,000 miles from Earth, descended into the depths of the planet, of the moon. That's got to excite the imagination. Going down there to learn about scientific discoveries and the engineering possibilities for making this possibly a site for human settlement. To me, it's like a metaphor of a Jules Verne novel, Journey to the Center of the Earth metaphor. So why are caves important? Well, first of all, they offer protection from the lunar environment, the harsh environment of space, the ability to protect ourselves from micrometeorite bombardments and radiation and lunar dust and the extremes of the temperature changes that go on there. The caves are benign environments. They give us a better idea of how to design systems and materials so that they can accommodate that environment. This cave that I'm showing you right now is the largest cave we have on Earth. It's a cave in Vietnam. And this is sort of what a sense of scale for you of what we think the size of these caves are on the moon. Now, one of the other reasons we want to go there is economic reasons. Mining. We believe there are resources up there to mine and harvest for living off the land and also for export. Titanium could be mined up there for the lunar settlement to help build and fabricate the metals that we need to have to construct, extract water and extract oxygen so that we could use fuels to build fuel stations for ships going on to Mars to lower the cost of transportation. And even helium-3, a nuclear fusion material for export back to the Earth as a power source once the technology of those reactors become available. Okay, so how does San Antonio do this? Where do we begin? To me, it's collaboration and education. You'll hear later today another speaker talk about collaborative ecosystems and how they spawn entrepreneurship and innovation in startup companies. But education is another starting point that we should look at. This map says that our STEM workforce needs to grow a little bit. San Antonio's made great strides in the last decade. We're a city on the rise, but we need to continue to develop that workforce to create those STEM jobs: science, technology, engineering, and mathematics. That's what STEM is. And we can use the context of a lunar base, a community-sponsored program that says we're going to go build a lunar base on the surface of the moon, and we're going to do it out at San Antonio by building new companies, new technologies, starting right here. And we're going to educate our workforce as a way to start that process. So let me take you through a series of steps, scenarios, if you will, of how this lunar base would be constructed. From the pristine site, undisturbed, to the end state at the end of the century, when there's a full-blown settlement there. As an architect, you have to have a knowledge of the site. You need to know how to characterize it. You want to know what's there. You want to be able to map it out, discover where the ore fields are, where they're located at, how that happens to be in relationship to your spaceport, because after all, a lunar base is a spaceport. You need to know approaches to the hole. We want to measure every nook and cranny, every rock that's out there. And we can do that right now We can do that right now by remote sensing techniques with data sets we have from currently orbiting lunar satellites to help us do that. The next phase after that is the reconnaissance phase. Robotic reconnaissance, sending robots there to measure with scientific instruments what's out there, what's down there. Let the scientists take all the field measures they can get. But there's a problem, access. They're very dangerous, these caves, getting in there. They're deep, steep cliffs. Getting an astronaut in and out of the hole is a problem. We need to have some solutions for that. So here's just a notional idea of throwing a cable across the pit so that, from a deployment platform, and then taking the science instruments and let them lower themselves down so that they can get to the bottom of the pit and do the measurements. Now, I show you this because this is one example of how we can use students and getting STEM programs involved to help solve some of these problems. Here's a site here in San Antonio over by Northeast Stadium. Perfect site for staging these programs. To bring students in and to help them learn about robotics, make them build their own zip line so they can learn about the common communications and the power systems and give them a hands-on experience. Give them something to be a part of, a real mission. Let them know that we are looking at really doing this, and you can be part of it. You're a part of something grand, a grand idea. Now let's go on to the next stage of this reconnaissance phase. The humans start coming here. This is the first time we actually stay in the cave. We bring the humans in there to ground truth the measurements we had because of, the humans can only do that in such a way that robots can't do, and we want to really look at the ability to whether or not this cave is actually viable. These will be short duration missions, 2 to 3 days at a time, temporary. And they can also be learning about inflatables, human habitation, these student programs as well. Let's go to the next phase. This is probably the end of the next decade to the middle of the century when we start putting in modules and we learning how to actually live there for a little bit longer periods of time, weeks to months at a time. Probably the first mining operations are occurring at the same time. Again, potential for student programs to be able to learn about human factors, psychology, agriculture on the moon. All these things can be part of our curriculums that we develop here in the community. So now we start looking about mid-century, the settlement phase, the idea of long-term stay, bringing in the infrastructure, all the mass materials, this heavy-duty machinery. This is a lot of stuff going on here by the time we get there, but this is the time when we start thinking this is permanent settlement, and people live in there for longer periods of time. And finally, end of the century, we have a full-blown settlement. We've doubled the capacity of the volume there. We put a pressurized dome over this hole to alleviate ourselves from the constraints of spacesuits and get out of the modules, give us more room to move around it. Now you look at that picture. There's a lot of technology that goes into putting something like this up there. And where's that technology coming from? The community that sponsored it, right back here. The companies that were developed, the innovations that occurred, new business that happened that pushed us out to the needs up there, as well as the needs down here on Earth. You can't tell me that the economic development of this lunar base is not tied to the economic development of the community that sponsored it, San Antonio. The STEM workforce marches right along with it. So my message is, if we really want to step into the 21st century, why don't we use the inspiration of commercial space exploration and literally shoot for the moon? Thank you very much.